Hello. In this video, we are going to see some of the features that were left out from the previous video due to time constraint. We're going to load peripheral blood mononuclear cell single cell data, which is publicly available from the data sets provided by 10x. And in this data set, there are two experiments that have been merged, and we are going to visualize a gene expression of gene CD68. When you click plot expression, you get a violin plot, as you might have seen in the previous video. Now, I'm not interested in all the other clusters except 1, 7, and 8, which shows the maximum expression of this gene. So how do you select that? In the select cluster to plot, you select 1, 7, and 8 and plot expression, and this will limit the violin plot to this particular, these three particular data sets and show you create a new data set. You might have also noticed that the count data was also now focused on that particular data set. You can not just do it for violin plot, you can also do it for feature plot or any other kind of plot that you have. So here the feature plot is shown for CD68, which is focusing only on 1, 7, and 8, the clusters shown here. Next, you can also switch to a t-SNE view, which gives you a different way to plot the dimensional reduction. t-SNE uses different mathematical formula and different approach to construct this dimensional reduction. UMAP is better for larger data sets as its performance is quantified to be better. But t-SNE and UMAP work almost similarly for cells up to 100,000 or 200,000 cells. UMAP condenses the clusters more concisely, and the gaps might be more obvious in UMAP. But in t-SNE plot, you see the cells spread out more, and therefore any subtle expression of gene in a subset of cells can be captured here. You can also click on show number of genes per cell. This will show you if any cluster has very high levels of number of genes expressed in them or low levels. And if you want to check if this is because of a biological property or if it is because of technical issues, you can click on the number of EOMIs per cell. This will give you the number of reads mapped in each of these cells, and this shows that these cells actually have lower number of reads assigned to them, while cluster 5 and 8 have higher number. You can also choose to overlay a metadata on top of this. So here I'm going to choose the experiment that gave rise to these two data sets, and you can see that there are two different experiments that were combined in this data set, and these two are their distribution. You can also split the data based on that, and this will give you the clusters that were derived from experiment 1 and experiment 2. Notice the difference for cluster 3 and cluster 5. And finally, there's an option to add pseudo-time analysis now, performed using Monocle. That will be shown in another video. Thanks for watching.